my dear students. Let's start the session.
Kinematics of rotating body. Kinematics of rotating body. We are discussing. You can discuss in the different manner. Same thing, same approach, same thing. Now we need to apply the vector approach. So vector, you should be very comfortable in the vectors. See here. This is the rotating body. See this. Here to here, velocity at point A. This is A and B. AB is the rigid body. This is the rigid body or rigid link. Rigid body. We are discussing kinematics of rigid bodies. Here up to which chapter? Up to gravitation. Total all bodies are assumed to be rigid body. What is rigid body? When you apply infinite amount of force on the body, negligible deformation. Clear? So here we can take this is omega, angular velocity of the link BA. Clear? So what is the velocity at point B with respect to point A? Velocity at point B. How to name this? It's a vector. Velocity at point B. Velocity at point B with respect to point A. Velocity at point A with respect to velocity at point B with respect to point A. So here, we need to draw the perpendicular. Clear? Velocity at point B with respect to point A. This is what? Drew the perpendicular. Velocity at point B with respect to point A is acting tangential to the rigid body. Tangential to the rigid body in the same sense of omega. Clear? So here, velocity of point B with respect to point A. With respect to point A, observer sitting at point A. Observer observing the motion of point B. Clear? By sitting at point A. Point A is what? Stationary position. Observer sitting at stationary position. Observer sitting at stationary position. Velocity at point B with respect to point A. Velocity at point B with respect to point A. What is the velocity of point A? 0. That equal to velocity at point B. This is what? Relative velocity. Relative velocity of point B with respect to point A. Relative velocity of point B with respect to point A. What is VB? absolute velocity of point B, absolute velocity of point B, absolute velocity of point B, absolute velocity of point B. When the relative velocity becomes absolute, when the relative velocity becomes absolute, when the observer sitting at stationary position, the relative velocity becomes, the relative velocity becomes, relative velocity becomes absolute velocity, relative velocity becomes absolute velocity when the observer sitting at, when the observer sitting at, when the observer sitting at stationary position. So in last case, what we did? So we took instantaneous center as the reference point. Whatever the velocities obtained by instantaneous center method, all are absolute velocities, because you are observing the motion of the body sitting at instantaneous center, so called zero velocity point, so called stationary point. Understood? Are you clear or not? Now tell me, what is the position vector? How to take the position vector? How to take the position vector? Position of point B with respect to point A. Position of point B with respect to point A. How to read this? Position of point B with respect to point A. See this, position of point B, position of point B with respect to point A, position vector of point B with respect to point A, with respect to observer sitting at that point, with respect to vector should come from that point, with respect to vector should come from that point. Clear? That is the position of point B with respect to point A, with respect to point A. Now how to write in the form of vector? So now tell me, how to write velocity of point B? See this, velocity of point B with respect to point A, with respect to point A, that equals to how much? Angular velocity of the link BA crossed with position of point B with respect to point A. Omega bar cross R bar is the rotating component of velocity. Understood? Position of point B with respect to point A. Velocity of point B with respect to point A. Omega. What is the direction of omega? Direction of omega. Plus k cap or minus k cap. This is plus k cap or minus k cap. Plus k cap or minus k cap. Minus k cap. Okay na? Fold your fingers in the direction inward. Minus k cap. Outward. Plus k cap. What is the direction of rotation of the fan? Clockwise or anti-clockwise? Clockwise or anti-clockwise? Anti-clockwise. Rotate it. Angular velocity downward. Air flow in the direction of angular velocity. Clear? So if it is rotating anti-clockwise direction, this is anti-clockwise direction, downward. Understood? Downward. X, Y, Z. X reference is what? X, Y, Z. K cap will come. Understood? So that is the direction of angular velocity. Omega k cap. This is velocity of point B with respect to point A. Now write down. Now we can take the one case completed. Now we can check it out. Check it once. Now check it once. Now I am taking one instant at a particular instant of time. At a particular instant. See this. The position of point A and point B like this. Position of point A and point B like this. This is the point B, exactly perpendicular. Perpendicular. Okay now. At this particular instant of time, what is the direction of velocity of point B with respect to point A? See this. At this particular instant of time, omega BA equal to how much? It's a vector that equal to how much? Positive or negative? Positive or negative? Inward. Inward. That is how much? Minus omega k cap. Minus omega k cap. Radius of rotation will be smaller. Position vector is how much? Position vector. This is how much? Here to here. What is happening? See this. See this. This is the position vector. This is the position vector. Position vector of point B. Position vector of point B with respect to point A. That equal to how much? R. You can take length R, capital R. You can take capital R. R J cap. This is how much? R J cap. Upward. R J cap. Now tell me. Velocity at point B with respect to point A is defined as the omega R. Omega bar cross R bar. Omega bar cross R bar. Omega bar cross bar. Omega bar cross R bar. What you will get? This is how much? Minus omega k cap crossed with. This is how much? R j cap. R j cap. K bar cross k cap cross j cap emaitadi. This is minus omega. This is how much? Minus omega r. K cap cross j cap. K cap cross j cap is how much? K cap cross j cap how much? K cap cross j cap how much? Minus I cap. Minus I cap. Omega r. Minus omega r. This is how much? Minus I cap. Minus into minus plus. Omega r. Omega r I cap. Velocity at point B with respect to point A. It is along which direction? Which direction? I cap direction. So we already know the sign convention. Okay na? So in the same sense of omega. In the same sense of omega and tangential to the rotation of the rigid body. This is how much? This is how much? Both are matching or not? Omega r. This is along which direction? I cap direction. Understood? It is acting perpendicular to the rigid body in the same sense of omega and tangential to the rotation of the rigid body. Matching or not? I cap is coming. I cap is coming. Omega r I cap. Omega r I cap. So if you take see this. If you take another sense, okay na, see this, here to here, this is the rigid body A. Now tell me, here to here, this is the rigid body B, AB. It is rotating in this particular direction. Opposite sense, in this particular direction, omega BA bar. Omega BA bar. If it is rotating in this direction, okay now, is it clockwise or anti-clockwise? This is clockwise. Clockwise. This is what? Clockwise. Clockwise. This is clockwise. Keep clock on the board. Tick, tick, tick. Clear? clockwise, inward. Clear? This is what? Keep clock here. Tick. Anti-clockwise. Outward. That is how much? Omega K cap. This is the reference we are taking here. X. This is along I cap. This is Y. Y J cap. This could be Z K cap. Omega K cap. Now tell me, what is the velocity at point B with respect to point A? So what is the position vector? What is the position of point B with respect to point A? What is the position of point B with respect to point A? Position of point B with respect to point A, that equal to how much? Length of the rod. That is how much? R J cap. Clear? So what is the velocity at point B with respect to point A? Velocity at point B with respect to point A. Omega BA bar how much? Omega K cap crossed with R J cap. That is equal to how much? Omega R into K cap cross J cap minus I cap. K cap cross J cap how much? Minus I cap. Omega R into minus, this is minus I cap. Velocity at point B with respect to point A how much? It is along negative x-axis. This is along negative x-axis. Are you getting the same? Negative x-axis. This could be negative x-axis. Velocity at point B with respect to point A. That is along negative x-axis. Our sign convention also matching or not. So here VBA is acting tangential to the rotation of the disc in the same sense of omega. If this sense is like this, VBA bar must be in this direction. Are you getting the same? This is how much? Minus omega R I cap. Minus omega R I cap. This is velocity. Now coming to the acceleration analysis. This is velocity analysis in plane motion. Now we need to introduce acceleration. When the body is rotating, how many accelerations associated with the rotating body? How many accelerations associated with the rotating body? Cheppandi. When the body is in rotary motion, how many accelerations will come? How many accelerations you studied till now? Centripetal acceleration. Centrifugal force will come. Centripetal acceleration. So-called radial acceleration and tangential acceleration. Right now, acceleration analysis completed. This part done. When the body is rotating, this is the rotating body. For rotating body, see here. Focus here. This is acceleration analysis of rotating body. See, we are discussing kinematics of rotating body. Velocity completed. Now we need to talk about acceleration. Analysis of acceleration analysis in rotary body dynamic kinematics, rotating body analysis of rotating body, acceleration analysis of the rotating body. First we need to talk about rotating body. After that, rolling, acceleration analysis in rolling, velocity analysis in rolling completed, velocity analysis of the rotating body by using vector approach and scalar approach both completed. Now we need to talk about acceleration analysis of rotating body. Acceleration analysis of rotating body and circular motion, acceleration analysis more or less same. Clear up? After that we can connect it. I will tell you the difference between rotation and circular motion. Rotary motion, circular motion different. Clear up? So now we need to analyze acceleration analysis of rotating body. Focus here. Same story here also. Same story here also. See this. This is how much? Here to here. This is the point B. This is the point A. It is rotating. Omega BA. This would be alpha BA. This is angular acceleration, angular velocity. So here to here, RBA. Position vector. See this. Here to here. This is how much? Position of point B with respect to point A. Position of point B with respect to point A. Here to here. It is having two accelerations. When the body is in pure rotation, it is having two accelerations. One is radial acceleration. Here to here. Radial acceleration. This is the radial acceleration at point B with respect to point A. This is termed as radial acceleration at point B with respect to point A. Write down. Radial acceleration at point B with respect to point A. So how to write this? Radial acceleration. Radial acceleration at point B with respect to point A. Radial acceleration at point B with respect to point A. So what is the magnitude and direction of it? I will derive this part. See here. What is the magnitude of radial acceleration? Omega square r. This is, it can be written as V square by R. V equal to omega. Clear up? This is the magnitude of radial acceleration. What is the direction of radial acceleration? It always acts. Okay, now from point B to, it always acts towards the center of rotation of the body. Clear up? It always acts towards center of rotation of the body. So we can confidently say that radial acceleration as centripetal acceleration. Centripetal means what? It always acts towards the center. Centrifugal means what? It always acts away from the center of rotation of the body. This definition is valid for circular motion also. Clear? So we can call radial acceleration as centripetal acceleration. Centripetal acceleration. Okay now, centripetal acceleration. Clear? So when the body is in rotation, for rotating body, radial acceleration is compulsory. Radial acceleration is, you can write, radial acceleration is compulsory. Underline compulsory. Without radial acceleration, there is no rotation and circular motion. Whatever the body is in, rotating or in circular motion, in both the case, radial motion, radial acceleration not equal to 0. Radial acceleration can't become 0. Radial acceleration can't become 0. What is the reason for existence of radial acceleration? What is the reason for existence? Of radial acceleration? It is due to change in direction of velocity at a point. Due to change in direction of velocity. Due to change in direction of velocity. Due to change in magnitude of angular velocity, tangential acceleration will come. Due to change in direction of velocity, not angular velocity. Clear? See here. So in what manner you can explain this? This is the body. Here. So at every particular instant, the direction of velocity at point B is continuously changing. Correct or not? Take this point. Here to here. What is the direction? This. Like this. It is continuously changing. Understood? So due to change in direction of velocity, okay now, due to change in direction of velocity V, due to change in direction of velocity, radial acceleration will come. Without change in direction of velocity, this rotation itself not possible. That is why it is compulsory. In order to become magnitude-wise radial acceleration, in order to get this 0, omega should be 0. Omega 0 means there is no rotation. That is why it is compulsory. Understood? Radial acceleration. Radial acceleration is compulsory. That is because of change in direction of velocity at every instant. Clear? So entire body if you take this point, this velocity at any point, the direction of velocity is continuously changing because of change in direction. Radial acceleration will come. Coming to tangential acceleration. Tangential acceleration at point B with respect to point A. It always acts tangential to the circular motion or else rotary motion of the body. It acting tangentially in the same sense of alpha. It always acts tangentially in the same sense of alpha. It is acting from B to A. What is the direction? B to A. B to A. It acting from B to A. Acceleration at point B with respect to point A from B to A. Now, tangential acceleration. This part completed. Now, tangential acceleration. So here we can write tangential acceleration. What is the tangential? How to write this? Tangential acceleration. Tangential acceleration at a point B with respect to point A. With respect to point A. With respect to A. With respect to A. So what is the magnitude of it? What is the magnitude of tangential acceleration? Magnitude of tangential acceleration at point A with respect to point A. At point B with respect to point A. This is nothing but alpha r. This is alpha r. So we can write it as alpha r. So what is the direction? It always acts tangentially. It always acts tangentially. It always acts tangentially. Tangentially and in the same sense of alpha. In the same sense of alpha. In the same sense of alpha. What is the reason for existence? What is the reason for existence of this? Reason for existence. Due to change in magnitude of angular velocity. Due to change in magnitude of angular velocity omega. Angular velocity omega. Directional velocity here we need to write, not direction of angular velocity. Direction of angular velocity, of course, either k cap or minus k cap. Here, we are talking about v equal to how much? Omega. The direction of velocity itself changing. Here, due to changing magnitude of angular velocity, then alpha ba equal to how much? T omega ba by dt. Rate of change of angular velocity is nothing but angular acceleration. Angular acceleration. So for uniform circular motion or uniform rotation, for uniform circular motion or uniform rotation, for uniform rotation means what? Uniform rotation. Omega must be constant. For uniform rotation, omega is constant. Alpha becomes how much? D omega by dt, that equal to 0. Tangential acceleration becomes 0. Tangential acceleration, alpha into r equal to 0. That is why tangential acceleration for rotating body is optional. Tangential acceleration for rotating body, tangential acceleration for rotating body is optional. Rotating body is optional, but radial acceleration is compulsory. Tangential acceleration is optional. In case of uniform rotation, angular velocity constant, angular acceleration 0, tangential acceleration 0, even though the body is in rotary motion. Understood? For uniform circular motion also same case. The expressions we used in rotating body and circular motion exactly same. Clear? This is pure kinematics. Acceleration analysis of rotating body. Here, radial acceleration at point B with respect to point A. The magnitude of radial acceleration is omega square r. We can replace V equal to omega r here. V square by r. It always acts towards the center of rotation of the body. Clear? This is the direction of radial acceleration. We can call radial acceleration as centripetal acceleration. For rotating body, radial acceleration is compulsory. So why are you taking it as compulsory? In order to become radial acceleration 0, either omega r must be 0. R is 0 means there is no length, it's a point. Point is rotating, meaningless. Understood? So here omega, the rotation of the point object you can't observe. The rotation of the point object you can't observe. Okay, now r can't become 0. If omega 0, then the body is not in rotation. There is no meaning of the putting radial acceleration. Body itself not rotating. What radial acceleration you are talking about? If the body is rotating, then radial acceleration is compulsory. What is the reason for existence of radial acceleration? Due to change in direction. Rotation. Why two acceleration exist? In translation, only one acceleration, linear acceleration. Why two accelerations in rotary motion? One is due to change in direction, but there is no chance of change in direction in case of linear motion. If magnitude of linear velocity is changing, linear acceleration will come. Understood? So linear motion in a straight line. Clear? There is no change in direction of velocity. But here, direction of velocity changing, magnitude of angular velocity changing. That is why two accelerations will come. Understood? Why two accelerations in rotary and circular motion? Why only one acceleration in pure translation? That is the reason. Here, tangential acceleration, this is the magnitude. It always acts tangentially. That is why name is given as tangential acceleration. In the same sense of alpha. This is the sense. Same sense. Understood? So, tangential acceleration is optional. Understood? This part done. Now write down. Same way. How to explain this? See here. Now I am interested in vector approach. Acceleration analysis in vector approach. See here, vector approach. So in order to check it, so we can draw like this. We can do like this. See here. This is the point B. This is the point A. Here. This is what? Here to here. This is omega BA. Omega BA. This is how much? Alpha BA. Alpha BA. What is the position vector? This is the position vector. Position vector. Position vector. Position of point B with respect to point A. That is length of the radius of rotation of the rigid body. R J cap. Alpha B equal to how much? Alpha BA. This is how much? Plus K cap or minus K cap? Minus K cap. Clear? So it will come. Entire discussion came from velocity. What is the velocity V bar? Velocity at point B. Velocity at point B with respect to point A. That equal to how much? Omega bar. Omega BA bar crossed with R bar. This is A. Understood? Clear? So now differentiate. Now we need to talk about, just for avoiding confusion, V bar equal to omega bar cross R bar. Omega bar cross R bar. Clear? Understood? Now differentiate with respect to what is the acceleration? A bar equal to how much? dV bar by dt. We know or not? dV bar by dt. So how to differentiate? Apply XY rule, UV rule. First we can differentiate R. After that you can differentiate omega. Or else first you can differentiate omega. That is up to you. UV rule. So here omega bar cross dr bar by dt. It's a this vector product, cross product, plus how much? d omega bar by dt crossed with r bar. Understood? Okay now, dr bar by dt is nothing but velocity V bar. V bar equal to how much? dr bar by dt. R bar equal to how much? X I cap plus Y j cap. Clear? So if you differentiate position vector, you will get velocity. That equal to how much? Omega bar cross V bar. Plus how much? Alpha bar cross R bar. Understood? So now we can write V bar can be written as omega bar cross R bar. This is how much? Omega bar cross R bar. Plus alpha bar cross R bar. That is the net acceleration. That is the A bar. You can confidently say that first term related to radial acceleration. Radial acceleration bar. Okay now, this term related to tangential acceleration bar. That is A bar. A bar equal to how much? Radial acceleration plus tangential acceleration. You can write separately. What is the radial acceleration? Radial acceleration equivalents to how much? Radial acceleration equal to how much? Omega bar cross. Omega bar cross. R bar. R bar. R bar. What is the tangential acceleration? Tangential acceleration in the form of vector. Alpha bar cross. R bar. Alpha bar cross. R bar. Alpha bar cross. R bar. This is radial. R refers to radial. T refers to tangential. Tangential acceleration. Now we can confidently write. Here you can write. Here you can write. Radial acceleration at point B with respect to point A. Radial acceleration at point B with respect to point A. Omega bar BA crossed with, tell me, omega bar BA. This is position of B with respect to point A. Position of B with respect to point A. Then what you will get? What you will get? This is equal to how much? Omega into minus K cap. You can write alpha minus K cap. So you can write it as, omega. How much is this? Minus omega K cap. Minus omega K cap crossed with minus omega K cap. Minus omega K cap crossed with, this is how much? This is how much? R J cap. R J cap. Are you getting the same? Minus into minus plus. Then what you will get? Take magnitude omega square R. Is it matching with the magnitude of angular velocity? Magnitude of radial acceleration. Now tell me. K cap direction. K cap crossed with J cap. K cap crossed with J cap. What is the K cap cross J cap? What is the K cap cross J cap? K cap cross J cap minus I cap. Minus I cap. What is K cap cross I cap? I J cap. Clear? So omega square R into minus J cap. So it is along. Radial acceleration of point B with respect to point A. It is along negative towards the center. Our definition also change same na, matching or not. Radial acceleration at point B with respect to point A, that equal to omega square R. It is along negative y axis. This is from B to A. It is from B to A. A is the center of rotation. Are you getting or not? Are you getting the same? Understood or not? That is the radial acceleration. Now coming to tangential acceleration. At point B with respect to point A. Alpha BA bar crossed with position of point B with respect to point A. Then alpha BA bar is how much? Minus alpha K cap. This is how much? R J cap. Now tell me, this is minus alpha. Magnitude is matching. K cap cross J cap. K cap cross J cap. How much will come? Tell me. K cap cross J cap is how much? Minus I cap. Minus alpha R into minus I cap. Minus into minus plus. Alpha R into I cap. That is the tangential acceleration at point B with respect to point A. Positive direction of x-axis. We can confidently say that positive direction of x-axis tangential acceleration. This is what? Tangential acceleration at point B with respect to point A can be written as alpha r is the magnitude, positive direction. It is acting tangentially. That is matching or not? Tangentially. In the same sense of alpha, that is also matching. So this is the vector form. This is the vector form of radial and tangential accelerations. Radial and tangential accelerations. First you have written v bar equal to omega bar cross r bar. Differentiate with respect to time. This is the way to differentiate. This equation is very important. Here don't change the parameters. Straight away as it is you can write. First differentiate this. First differentiate this. After that keep omega here only. Keep differentiate this. Okay now differentiate this. Are you following? Then dr by dt replaced with v bar. V bar replaced with omega bar cross r bar. D omega by dt replaced with alpha bar. Understood? Alpha bar cross r bar. Alpha bar cross r bar. Are you clear? Alpha bar cross r bar. Omega bar cross r bar. Completed. Now. Here you can write V bar equivalents to omega bar cross R bar. V bar equal to omega bar cross R bar. Omega bar cross R bar. From here we know that here dr by dt, dr bar by dt, that is equal to v bar. Dr bar by dt equal to how much? V bar. From here radial acceleration equal to omega bar cross r bar. Omega bar cross r bar. Here. This is how much? D omega by dt equal to how much? D omega bar by dt equal to how much? Alpha bar. That is how much? Tangential. That equal to how much? This is the vector. That is equal to how much? Alpha bar cross R bar. Clear? So A bar equal to how much? dV bar by dt. That equal to radial plus tangential accelerations. Okay, now completed. Here, radial acceleration, tangential acceleration. Okay. So now, here, this is tangential. Okay. So here, this is what? Centripetal acceleration. Opposite to the centripetal acceleration, So we can represent analysis, acceleration analysis in circular motion, circular motion, circular motion, circular motion. Same story here also, same story. Focus here. This is the circular motion. This is the center of the here. This is what? Here to here, radius of the particle. This is the particle. Particle. Particle of mass m is rotating. Particle of mass m is rotating along the circle about this axis. Then the motion is called circular motion. In the circular motion, we need to treat the body as a particle. We need to treat the body as a particle. Velocity at any point on the particle is what? Same. Clear? So here, what is the direction of velocity here? This is the direction of velocity. Omega r. Omega r. Direction of velocity in the same sense of omega. Radial acceleration. You can take radial acceleration always act towards the center of circular motion. Yeah, tangential acceleration. Tangential acceleration always act. Tangential, this is omega square r. This is equal to alpha r. This is equal to alpha r. Understood? We also acting in the same direction. Tangentially, this is omega. Are you following? Understood or not? Now, opposite to the direction of this, you can call it as radial acceleration called as centripetal acceleration. Centripetal acceleration. Centripetal acceleration. Centripetal acceleration. In the rotation, focus here. In the circular motion, see this. This is the center. This is the center. It's a particle of mass m. Particle of mass m. Radial acceleration is what? Along this direction. Radial acceleration along this direction. What is the inertia force in circular motion? Inertia force in circular motion. Inertia force in circular motion is centrifugal force. Centrifugal force. Centrifugal force. Inertia force in circular motion. Inertia force in circular motion. Inertia force in circular motion. Centrifugal force always act opposite to the direction of centripetal acceleration. Centrifugal force equal to mass into radial acceleration. Centrifugal force always act opposite to the direction of centripetal acceleration. Centrifugal force always act opposite to the direction of centripetal acceleration, so called radial acceleration. Okay na? So mass into inertia force equal to what? Mass into acceleration. Mass into radial acceleration. We can call it as the magnitude of centrifugal force would be m omega square r. radial acceleration equal to omega square r. This is the acceleration analysis in circular motion. Kinematics in circular motion. Entire part is kinetics of rigid bodies. Understood? Acceleration analysis in circular motion. Same expressions will come here. Clear or not? Radial acceleration. Centrifugal force always act away from the center of circular motion. Centripetal acceleration always act towards the center of circular motion. Centripetal acceleration always act towards the center of circular motion. Centrifugal force always act away from the center of circular motion. Centrifugal force always act opposite to the direction of centripetal acceleration. Centripetal acceleration means radial acceleration. Understood? Now write down kinematics in rolling. Kinematics in rolling. Time ఎంత అయింది?